This is the Smart Buildings Academy podcast with Ethan Morris, episode number 522. Welcome to the Smart Buildings Academy podcast. In today's episode, we'll be learning how to troubleshoot common HVAC control failures. All the information covered in this episode can be found on our website at podcast.smartbuildingsacademy.com/522. Again, that's podcast.smartbuildingsacademy.com/522. So in today's episode, we're going to discuss troubleshooting some common HVAC control failures. So this episode matters because 70% of our comfort issues are typically BAS related. So the goal by the end of today's episode is to diagnose some of these failures within 30 minutes or less. Some of these troubleshooting steps can be pretty easy to do or handle or perform. But we need to remember that most HVAC issues are caused by controls, not mechanical issues. So today we're going to cover fast, repeatable steps to diagnose those common failures. Let's jump in. So to start off here, we're going to talk about the 30-minute troubleshooting framework. So the first thing here we're going to start off with is defining the symptom. So when we go through our system, we need to be looking for things. If we have something that's wrong, we can look at temperature sensors. Maybe we have a temperature sensor that's not reading the right temperature reading. These symptoms could be anything from outputs to inputs to, even mechanical equipment that we are controlling. But we need to define this symptom so that we know where we need to go and to go look for these issues. And then we'll know what the actual symptoms are, so we kind of have a plan in place when we go to start doing these checks. So after we've defined the symptom, next thing we can do is check the physical conditions of either the device or the equipment, whatever it might be. But the symptom, if you have something that's not responding at all, a temperature sensor or an output device, it could be damaged. Could have been somebody may have been working in there, maybe broke the sensor or broke a relay off of a starter or something. So we need to go out to these devices or the controllers, just verify the physical conditions of them first, and that includes wiring and the sensors themselves. So then once we've checked those physical conditions, if those look okay, next thing we can do is review our BAS data. So this could be looking at trend charts or trend logs, could be looking at alarms that come in. Maybe we have alarms telling us that some of these things have gone wrong. Those alarms and those trend charts can tell us a lot of information, and they can kind of help point us in the right direction while we're doing these troubleshooting steps. So with all those three things done, the next thing we should do is verify that our inputs are working, verify that our outputs are working, and then verify those are working per the sequence. Okay, so I know I talked about, verifying input devices and output devices up there in an earlier step, but now we're going to verify those with the sequence of operations. Okay, so what we're going to do is we're going to pull the sequence out, and then we're going to go to our input devices and our output devices, and we're going to verify that they are running and operating per how the sequence is telling us how they should be running. If we go through all that and the sequences are working okay, everything's working logic-wise how it's supposed to, then I'd say we're okay there. But then we can move on to, while we're in the software, we can move on to looking for overrides or safeties that might be tripped. If we have, somebody may have went into the system, a building operator may have went into the system, and maybe they needed some hot water through a fan coil for a few minutes. Maybe they have a problem with the valve and they can't get it to open, or the logic maybe stopped working, the program maybe stopped working for that hot water control. So what they did maybe was maybe they overrode the hot water valve point to 100% open or open all the way, and then left it there. Maybe they forgot about it, but this is what it's telling us here, is to look for these overrides. If we have overrides in place, we need to check and see why it's overridden in the first place. Go through and take the override off, and then see if the device responds to the logic. If it doesn't, then I'd say maybe we have a logic issue. And if that's the case, obviously you're going to have to go through and read the logic, figure out what's wrong with it, and then also make sure that logic lines up with the sequence too. But if the point's overridden, go through, unoverride it, or take it out of override, and then see if your device responds how it's supposed to. If it doesn't, you've got an issue. Start your troubleshooting process there. And then the flip side of this is safeties. If we have alarms set up for a lot of these safeties, but check your alarm panel. If your alarm panel is telling you that you have a safety tripped, like a static pressure static pressure sensor maybe tripped on high static or something, that safety would shut your equipment down. So, when you go to troubleshoot these things, look on the software, see if you have any alarms or safeties that are tripped. It could save you a lot of time on these troubleshooting steps as well. So then, last thing here before we move on is to confirm the root cause. So, a lot of these things could be a wiring issue, might be the device itself, but you need to get down to what the root issue is of that device or the sensor, whatever it may be. Because somebody could get in there, maybe change some things, like I said, override a point. You just don't know. So if you get in there, make sure you're confirming what the root cause of the issue is, and then work from that root cause and then perform your troubleshooting steps. And then, guys, always remember that troubleshooting is just eliminating possibilities, right? So we have to follow these steps in order, and then the failures should become obvious if we go through all these steps correctly. So just remember, guys, we're going to try and get all these troubleshooting steps completed within 30 minutes or less. Just saves us on time and labor. And a lot of these troubleshooting steps can be used multiple times for different sensors, just different things you're troubleshooting. So next thing up here is we're going to go over sensor problems. So this would be our failure category number 1, so sensor issues. So common symptoms for these would be software reading wrong temperatures, bad airflow readings, could be a status showing on when it shouldn't be, could be a multitude of things. But these are the most common issues we see with like temperature sensors. We're getting the wrong temperature or no temperature at all. And then if we have like VAV boxes or air handlers, we could be getting some bad airflow readings. And if we have, if these fans in the air handlers are VFD driven, if we're getting a bad static pressure reading in the duct, that could really mess with our programming and how the fan is speeding up or slowing down as well. So all these things are really, really important to think of and remember as we go through our troubleshooting steps. So those are our common symptoms. The next thing here is the causes for these. So again, I was talking about wiring could be an issue or the sensor itself, but it could be a couple more things as well. So it could be a failed thermistor. So this is what I was saying with the failed or the bad sensor in and of itself. But then we could have loose terminations. We could have a bad termination at the sensor itself, or we could have a bad termination at the controller. But this was that point I made in the last part there about verifying physical conditions of these things. So you could go through, very first thing I'd do is verify, make sure my wiring is right, terminations are landed correctly, I don't have any cut wire or loose wire anywhere. And then third thing on this is our bad scaling. If we configure this point wrong in the software, it's probably not going to read right. So if we get a bad sensor and we have to change it out, we need to make sure that our scaling represents that sensor based off of what that sensor is. And that's very, very important to follow and very, very important to keep track of those things, because if the scaling's wrong, you're going to have a wrong reading. So those are some common causes as well. So the next thing is fast steps. So one of my favorite things to do when I was in the field, I would carry a handheld thermometer, but this thermometer was kind of a dual thermometer. So it had temperature reading, humidity reading, and CO2 reading all in one handheld device, which was great for me because I could go to any office or any space that we were conditioning. I could take that out and hold it right next to the thermostat on the wall. And I know a lot of you guys probably deal with combo sensors, like zone sensors that have space temperature, CO2, and humidity in them. But this handheld type sensor can be a huge help for you, and it can make troubleshooting these things a lot faster too. But you should use these handhelds to compare the readings on that handheld to what you're actually getting on the software, or what the actual reading from the sensor is on the software. If you do this, then you can kind of see, they should be pretty close. They're not going to be the same because they're two different sensors. Calibration may be a little bit different. That's okay, but you should still be within a couple of degrees. It shouldn't be too far off, but you can use this to kind of compare and see how far off you are. And then if your actual zone sensor or whatever sensor you're testing is way off from what your handheld's saying, I'd say you probably have a bad sensor. Probably need to get that changed out. So then we have got a real world example here of this. So sensor problems. Remember, we're talking about issues with sensors here. So this example here would be if we had an outside air temperature sensor stuck at 72 degrees. Think about what all that's going to affect for you guys. If you live in a colder climate area like I do here in West Virginia, There's our winter times. We use a lot of free cooling in our air handlers here because the the ambient air outside can get well below 55 degrees. And, typically 55 degrees is perfect for cooling. But typically when we get into the colder months here, we'll open outside air dampers and then we shut off chillers or any kind of cooling equipment we have. And then we can just cool based off of the outside air temperature. But on this example here, if my outside air temperature sensor was reading 72 degrees, it's never going to open that outside air damper for free cooling in the cool months because it's reading that's too high. So we need to make sure that we're checking these. Trend charts are a huge help on this front here because you can go back and look and see maybe when it messed up, or if it's stuck at 72, you can go back and see when it got stuck at 72. And then, you can replace it, see if there's an issue with your wiring, or maybe you got a controller wire that came out from that sensor. You never know. But always verify sensors with a physical meter. This will help you guys a bunch. And then use trend logs to reveal flat lines or spikes or impossible values. And this is where I was saying with that outside air example. If it's stuck at 72, if you go back and look at your trend log, you should be able to go back and see maybe when it got stuck at 72 and then what happened before that and right after that too. So this one here, again, this is our failure category number 1, and we're just going over sensor problems here. All right, so now we've done failure category 1. Next up, we're going to talk about failure category number 2. This one kind of leans more towards the output side of things. So we're going to talk about actuator and damper issues here. So common symptoms for these would be temperature swings, airflow problems, and economizer failures. The economizer failure, we could tie that in with our outside air temperature sensor getting stuck at that 72 degrees. It may present itself as an economizer failure, but what is controlling that economizer? It's going to be that outside air temperature. And if that outside air temperature is wrong or off, it's not going to, your outside air damper and that economizer is not going to work how it's supposed to. So our symptoms here, temperature swings, if we're talking about actuators and dampers, again, these are going to directly tie into temperature shifts because these are things that are going to help us condition the spaces that we're controlling. So common symptoms, again, if we're getting temperature swings, if we're getting airflow issues, or if we're getting economizer failures. The next thing here is causes. So a couple causes with those symptoms would be a damper that's bound. So it may be stuck. Maybe it can't open all the way or close all the way. You may have a crack in it. You may have some air leakage through that damper. Another one here is a broken linkage. If you have a actuator motor that is driving with a linkage, so it's a bar or whatever that's connected to the actual damper shaft itself, that linkage could get broke or it could just come off, screw it back out over time. If that's a case, you may need to fix that linkage, get a new one, and replace it in there. The binding damper, that typically goes in with the actuator being kind of canted a little bit off of like 90 degrees. But if it's not mounted correctly, you can get binding as it rotates that damper open and closed. So make sure when you mount that damper motor or the damper actuator that it's mounted flush, it's mounted straight, and you can open and close it all the way without any binding. And also you can check the damper before you mount the actuator to it. You can just take a pair of channel locks or something and rotate it all the way open and all the way closed, and just verify that the mechanical part of the damper works by itself before you put the actuator on. So that's binding dampers and then broken linkages. But then the other part of this is that we can also have reversed signals from our controller on this. So if we imagine these damper actuators or this valve actuator is a 0 to 10 volt actuator, if we have the scaling set up for that in the computer backwards, so it's thinking 0 is 100% open, and then 10 volts would be 0% open, that's backwards. Typically 0 is closed and 10 volts would be 100%. But this is saying if we had reversed signals, if you send it 10 volts, then it's going to close the damper. And in our brain, we're thinking about it the other way. That's not right. But you have to make sure that when you're setting these up in the software, you have to make sure that you're getting your facets right. Make sure you're getting all your conversions set up correctly too. So those are the common symptoms and causes for those. A couple fast steps here that we can check with these, a little additional that I put on here. But we can do just a visual inspection. Typically, you can go out and look, verify the physical state of these things, the devices, and the mechanical equipment as well. So start with visually inspecting those things. Next thing is the BAS command test. So go into the BAS, override the point, on or off, or modulate the actuator open or closed, and see if it's operating how you're commanding it to. And then if it's not, the last thing you can do is take a signal generator. You can check the signal. You can also take a multimeter and check it as well. So you can go either at the controller. So if it's a 0 to 10 volt damper, put it to 10 volts and then take a multimeter, put it on DC reading, and then check the two terminations on your controller to see if you're getting 10 volts DC output from your controller. If you're not and it says 0 and you should be getting 10, then you probably got your conversion backwards in your software. And then just a little real world example with this one too is just imagine if you had a rusted economizer damper shaft, okay? And this also ties in with the binding of a damper and airflow issues or an economizer failure. So if our economizer shaft had rusted and maybe seized, our actuators are only going to be able to turn so much. They're only capable of outputting so much torque. So if that shaft has become rusted or the damper has seized, you're not going to get that open. So you may have, if you're trying to use the economizer for free cooling, it may not open all the way. So your building may start getting really, really hot. But if your building's getting hot, check the things that are supposed to be cooling the building down. In this case, it's that economizer. When we go up and physically inspect this, we could see that it's just completely rusted over and that the damper is seized up and it just will not work. Even if we take a pair of channel locks and try to open it manually, just still won't work. So the big catch with this is just to remember to look, listen, and feel first. And then actuator and damper failures are often mechanical, not programming based. So just remember, we need to check the mechanical operation of these things as well. All right, so that was failure category number 2. Now we're moving on to failure category number 3. This one here is going to be VAV box issues. So common symptoms here would be low airflow because we have a damper we're driving open and closed in that VAV box pretty well all the time. Next one we have is hot or cold rooms, so nothing's staying temperate. Nobody's happy with the conditions of the room. And then we could also have noisy operation. So maybe if our damper's stuck, wide open, we may be getting a lot of air noise in our office. And a lot of people don't like that, especially if they have meetings or they're trying to get focused work done. Noisy operation is not a good thing for them either. So those are our common symptoms there. So a couple of common causes for these would be reversed flow sensors. So if we're reading low airflow, you may have your two tubes on your VAV controller backwards. So your low side's going to the high side, and then vice versa, the high side would be going to the low side. Make sure you put those on the right barb fittings on your controller. Next thing is it could be the wrong K factor. So the K factor is given to us by the manufacturer, and basically what it does for us is it converts the airflow reading into a CFM reading for us. So check and make sure that your K factor is right for the size box that you have, the size VAV box that you have. If you have the wrong K factor, you may get the wrong airflow readings as well. So double check those. And then, of course, this falls back in with the last couple slides there, but mechanical operation, talking about VAV boxes here, but check and see if you've got a stuck damper. This is a typical cause too. If you got a damper that got bound up or stuck, you're going to have way wrong airflow readings, may have a lot of noisy airflow coming into the room. And it could also affect your heating and cooling in that room as well. So that's the most common causes there. So then a couple fast steps with this is to check your airflow. You can take a manometer, handheld manometer, put it on your process tubes coming out of the VAV box, and you can verify what the airflow is out of that with that handheld manometer. Next thing is to verify that your K factor is right. Again, this ties in with what I said there a second ago. But if your K factor is wrong, you're not going to have the right reading, and it could even mess with your damper operation a little bit as well. Then the last thing here is to test the damper. So we want to drive it from 100% to 0%, make sure that it has full range of motion, and that it is getting to the 100% open and the 0% closed position. So then once we've tested all those things, again, I've got another little real-world example here for this one. So we have a school district here with 18 backwards VAV box airflow sensor tubes. As you can imagine, we would probably have 18 very, very, very unhappy teachers and students. So this here, basically what we'd have to do here is just go through. This would present itself as bad airflow readings, could present itself as too hot, too cold rooms, could be that noisy operation as well if the damper is wide open because it's thinking it's not getting enough airflow. This could present itself as noisy operation as well. But in order to fix this, you just have to go through and swap all your tubes back around on all 18 of these boxes, and then you should be good to go. But just remember, guys, on VAV boxes, the issues are highly, highly repeatable, okay? Airflow measurement mistakes are the number one failure source on VAV boxes. So just remember that. All right, that was failure category 3. Next up is failure category number 4. Now we're moving into logic and sequence errors. So the symptoms for this, these are going to be short cycling, so things just turning on and off, on and off, on and off rapidly. Next thing is simultaneous heat and cool modes, which is also not a great thing. A couple causes with these, we could have bad logic or bad PID tuning with these. We could have overrides that have been left overridden and in place. Also not something you want. And then we could just have logic errors. It could just be that the programming or logic was built incorrectly from the start, but we'll have to go back and recheck those. So fast steps here to fix those causes would be to check the overrides. Make sure those overrides are disabled, turned off, or released into their normal operation state. Next thing we can do is check our schedules. If we have a schedule conflict that's keeping something turned off or it's keeping something turned on longer than it should be, check these schedules, make sure that they're set up for your operational timelines. Then once we've checked those schedules, just go in and review these logic. Just review the logic that you have built and in place. Because like I said, if you have just improper logic, this could be causing a lot of your issues as well. Real world example for this one is a cooling mode output left overridden or active. And again, this is one of those things where it's going to represent itself as being, you probably go get a room that's going to be way, way, way too cold. Humidity is going to be way out of whack in there too. But again, we need to go in and just verify that any points we have are not overridden or they're not stuck in an overridden state. If they are, we need to take that out of the overridden state and put it into its automatic operation state. And then we need to go verify and check and make sure that's operating how it should once we release that override as well. If it's not, then we need to go back into some troubleshooting steps and see maybe if we have bad piece of logic, maybe we have a schedule that's caused a issue here or schedule conflict. Could be a couple things, but we're not going to know anything until we get that override disabled. But the big thing to remember, guys, is that you don't need to be a programmer to find issues with logic or any of this. All you have to do is take a sequence of operation and compare it to the actual behavior that you're getting, especially when you have an override that's been overridden. Take that override out, grab the sequence of operation, and then just read through the logic. It should match up pretty close to what the sequence says. If it doesn't, somebody's probably written some logic that probably didn't match up what the sequence was supposed to be, and you're probably going to have to fix that or get it resolved. All right, moving on to last category here, failure category number 5 of network issues. So very, very common for this one, but symptoms for this would be devices showing as offline, values getting frozen or not updating as they should, and then missing trend logs. So if we're missing trends or values from a trend, it's probably because we're having devices dropping on and offline a bunch. So this would tie in with our network issues. So common causes for these. We could have bad MSTP breaks. So if we have an MSTP network, the wiring for that is pretty finicky. So just make sure that all your wiring through that bus is good. You got continuity all the way through. Definitely verify your shielding is correct, and then make sure you have end-of-line resistors where they're supposed to be. And then also on the MSTP side, we need to make sure we don't have duplicate MAC addresses for our devices. This will cause intermittent communication failures as well. On the IP side of things, this could be bad IP addressing conflicts. You could have multiple devices with different IP addresses. You don't want that either. Everything has to have its own unique address. One device has to have one unique address. You could have cable breaks in your Ethernet cables between your devices. And then talking about the cables as well, you could have bad ends on your Cat6 cable. If you're making up the ends or your sub is putting the ends on the Cat 6 cable. It's really easy to get one of those wires swapped around in there, and you'll not get any communication if that's the case. A really good way to avoid the Cat 6 wiring issues is to get a pretty decent wire cable tester that you can test that Cat 6 cable after you get the ends on it, so you can verify that it is correct and you have a good wire. So then that's MSTP and IP networks both. So some fast checks to check both of these. So we need to do our physical check. So again, make sure that our wiring is all terminated where it's supposed to. Make sure we don't have any breaks anywhere. And then we also need to verify that our IP addresses and our MAC addresses are correct and unique for each device. Once we've done that, then we should be okay. You should have your issues fixed. But if you don't, we have a real-world example here. So again, this one goes in with the that duplicate MAC addresses or having multiple controllers on IP networks with the same IP addresses. But this is this would be a university campus having multiple MSTP devices and IP devices with the same IP address or same MAC address, respectively. So in order to check these, again, we're going to start in the software, and we're going to have to go through and just verify every device has its own specific, unique identifier. If it doesn't, go through and fix all those, and I would say you probably have your communication issues fixed or your network issues fixed. And remember, guys, that MSTP wiring behaves like plumbing. Any break disrupts everything downstream, and that goes in with not just MSTP, but IP networking as well. You got a broke cable, it ain't going to work. Just how it goes. All right, guys, so to summarize today's episode, we learned that we need to follow that 30-minute framework so that we're not wasting time. And again, remember, most of these troubleshooting steps can be completed within 15 to 30 minutes. So just try and maintain that 30-minute framework, just save you on time and labor. Then we learned to check our physical conditions on all these. So wiring, input devices, output devices, everything. Check all of it. The next thing here is to remember that most failures are repeatable patterns. So especially with like VAV boxes and those airflow issues that I was talking about, those are repeatable patterns. You know, if you have one that goes bad with airflow, check the next one, might be pretty well close to the same thing. Then the last point here is just to remember to build consistency so that we help build speed as we're doing these troubleshooting steps. So be consistent as we're going through our steps, and then remember what you do, what you find, so that the next time you go out to troubleshoot something, it's kind of familiar to you. So thank you for listening to the Smart Buildings Academy podcast. We hope you learned from this episode. If you found this episode valuable, please leave us a 5-star review on Apple Podcasts or Spotify. If you're watching this on YouTube, please like, comment, and subscribe. As always, this will be available on our website at podcast.smartbuildingsacademy.com/522. Again, that's podcast.smartbuildingsacademy.com/522. This has been Ethan with Smart Buildings Academy. I really appreciate your time, and I hope you have a great day.